The cabin built into the coal mine entrance glowed against the January darkness, while Gareth Bedweer stood outside measuring temperatures with instruments he had fashioned from scrap metal and mercury. Inside the rock-walled shelter, the thermometer read 68 degrees Fahrenheit, while the instrument in his hand showed the outside air at 5 degrees below zero, a 73-degree difference that would prove his neighbors had been wrong about everything. Before we explore how one Welsh miner's obsession with heat changed frontier survival in the Colorado coalfields, let us know where you're watching from. And if stories of forgotten innovation move you, subscribe, because tomorrow's tale is even more remarkable than this one. The cabin was too quiet when Gareth Bedweer pushed open the door at 6:30 on the morning of February 9, 1873. He had worked the night shift at the coal mine 3 miles outside of Leadville, Colorado, and the walk home through pre-dawn darkness had numbed his face, despite the woolen scarf wrapped across his mouth and nose. The temperature had dropped to 18 degrees below zero during the night, cold enough that his breath froze in his beard and the snow crunched like broken glass under his boots. The fire should have been crackling. Gwyneth always kept it going through the night when temperatures fell this low, feeding split pine into the flames every few hours to maintain warmth until Gareth returned from his shift. But the cabin was silent except for wind moaning through gaps in the log chinking. The fireplace held only gray ash and a few smoldering coals that gave off barely enough heat to feel from 3 feet away. Gareth dropped his lunch pail and crossed to the sleeping area in 4 strides. His wife lay in their bed with their son Reese curled against her beneath every blanket they owned. Both were absolutely still. He touched Gwyneth's hand and knew immediately her skin was cold, far too cold, the kind of cold that meant hours had passed. Reese was the same. The boy's face was peaceful, pressed against his mother's shoulder as if he had simply fallen asleep seeking her warmth. Gareth stepped back from the bed. He did not cry out. He did not collapse. He stood in the center of the small cabin he had built with his own hands 2 years earlier and understood with terrible clarity exactly what had happened. The fire had gone out sometime in the deepest cold of night, probably around 3 in the morning when temperatures reached their lowest point. Gwyneth had likely woken, tried to restart it, but had been too weakened by cold to succeed. She had gathered Reese close, pulled every blanket over them both, and waited for warmth that never came. In a cabin with 4 walls, a roof, and a door that latched shut, his family had frozen to death less than 6 feet from a fireplace stocked with firewood. He walked to the fireplace and placed his hand on the stones. They were cool to the touch. The fire had been out for at least 3 hours, possibly 4. In that time, the cabin's interior temperature had dropped to perhaps 10 or 15 degrees above zero. The small cast-iron stove in the corner had gone cold as well. The cabin had become nothing more than a box that slowed the cold rather than stopping it. Gareth looked at the walls he had notched and chinked, the door he had hung, the window he had fitted with oiled paper to keep out wind. Everything had been built according to standard frontier practice. He had done nothing wrong by conventional wisdom, but conventional wisdom had failed completely. His family was dead because the cabin he had built could not hold heat when the Colorado winter reached its cruelest extreme. Gareth buried Gwyneth and Reese on a hillside above Leadville 3 days after he found them. The ground was frozen 18 inches down, and it took him and Idris Llewellyn most of 2 days to dig graves deep enough. The mining camp. Ministers spoke words in English that felt empty compared to the Welsh hymns Gareth's mother had sung at funerals back in Carmarthenshire. 15 miners attended, standing in the cold with hats in their hands. Daffyd Maddox's wife brought food Gareth could not eat. When it was finished, everyone returned to their cabins and their lives, and Gareth returned to the cabin where his family had died. He did not go back to work at the mine. He had saved enough money from 2 years of steady wages to survive several months without income, and the mine superintendent told him to take whatever time he needed. Instead of grieving in the way people expected, Gareth became obsessed with understanding exactly what had killed his wife and son. He knew the surface answer. They had frozen when the fire went out, but he needed to understand the mechanics of that failure with the same precision he understood how coal seams ran through mountain strata or how timber supports distributed weight in mine shafts. He began measuring everything. He bought a thermometer from the assay office, an expensive instrument that cost him 4 days' wages, and he started recording temperatures. He measured the cabin's interior temperature every hour for 3 days straight, noting when he added wood to the fire and how quickly heat disappeared. He discovered that even with a strong fire burning, the cabin lost approximately 15 degrees every hour once he stopped feeding the flames. Within 4 hours of a fire going out completely, the interior temperature matched the outside air almost exactly. He examined the fireplace itself, measuring the dimensions of the firebox and chimney. The design was standard, a stone firebox 3 feet wide and 2 feet deep with a chimney that drew smoke efficiently. It worked exactly as intended. The problem was not the fireplace. The problem was that heat from burning wood escaped the cabin almost as quickly as the wood could produce it. The walls were the issue, or more precisely, the fundamental nature of log construction in extreme cold. Gareth started visiting other cabins in the mining camp, asking questions that made people uncomfortable. How often did they wake at night to feed their fires? How much firewood did they burn in a week during deep winter? Had anyone else lost family members to cold despite having shelter? The answers revealed a pattern. Every family fought the same battle against heat loss. Everyone woke multiple times per night to maintain fires. Everyone burned enormous quantities of wood just to keep interior temperatures marginally survivable. And yes, others had lost people. An elderly grandmother in the Pritchard cabin the previous winter, a newborn infant in a cabin on the north edge of camp, a sick miner who had been too weak to maintain his fire. The cabins were not adequate. That was the truth nobody wanted to acknowledge. Frontier log construction worked adequately in moderate climates, but in Colorado's high-altitude winter extremes, conventional cabins were only slightly better than no shelter at all. Gareth returned to work at the mine in early March, not because his grief had lessened, but because working underground gave him access to something he had started thinking about constantly, the behavior of stone under thermal stress. The coal mine where he worked extended 300 feet into a mountainside, following a seam of bituminous coal that varied from 4 to 7 feet thick. The tunnels were cold, usually holding steady around 45 degrees regardless of outside temperature, but Gareth had begun noticing something other miners ignored completely. The rock face in certain sections of the mine stayed warm long after heat sources were removed. Miners carried oil lamps that produced modest amounts of heat during their shifts. In most areas of the mine, the rock felt cold to the touch even after a lamp had been positioned near it for hours. But in sections where the rock composition was different, where the coal seam was backed by dense sandstone, or where certain mineral deposits were present, the rock absorbed heat and held it for remarkably long periods. Gareth started conducting informal experiments during his lunch breaks. He would position his oil lamp against a section of sandstone wall for the entire 30-minute break, then remove the lamp and place his hand on the rock at intervals to feel how long warmth persisted. The results varied dramatically based on rock type. Shale cooled within minutes. Limestone held heat for perhaps half an hour. But dense sandstone, particularly the gray variety with fine grain and few fractures, stayed noticeably warm for more than 2 hours after his lamp was removed. He began asking questions of older miners who had worked coal seams in Wales and Pennsylvania. A few remembered details that seemed irrelevant to coal extraction but fascinated Gareth. In Welsh mines, sections with certain rock characteristics were noticeably warmer than others. Miners sometimes took lunch breaks in specific chambers because the rock held residual heat from lamps and body warmth, creating spaces that felt less brutally cold than the rest of the mine. Nobody had studied this phenomenon or tried to explain it. It was just something experienced miners knew from observation. Gareth's understanding deepened through March and into April as he paid attention to thermal behavior underground. Stone had memory. That was how he started thinking about it. Rock absorbed heat energy and released it slowly over time, the rate of release depending on the stone's density, moisture content, and composition. A large mass of the right kind of stone, heated sufficiently, could radiate warmth for many hours, possibly through an entire night. The implications for cabin heating struck him one afternoon in mid-April while he was working a coalface 80 feet underground. He had been chipping at the seam for 3 hours, and the rock had absorbed heat from his body and lamp. When he stopped to rest, the stone wall behind him felt noticeably warm against his back. The rock was giving back the heat it had absorbed. What if a cabin could do the same thing? What if instead of fighting to heat air that escaped through walls, you heated the walls themselves? The idea seemed impossible at first, but Gareth could not stop thinking about it. Standard cabin construction used wood, a material that did not absorb or retain heat meaningfully. Wood was an insulator, which meant it slowed heat transfer but did not store thermal energy. You could heat a log wall with a roaring fire, and the interior surface might become warm to the touch, but the wood itself held almost no heat. The moment you stopped heating it, any warmth disappeared within minutes. Stone was different. Stone was thermal mass. A cubic foot of dense sandstone could absorb heat energy equivalent to warming it dozens of degrees, then release that energy gradually over many hours. The physics were simple. The challenge was figuring out how to build a cabin that incorporated stone in a way that took advantage of these properties. Gareth spent 2 weeks in April walking the mountainsides around Leadville during his time off from mine work, looking at rock formations and abandoned mine workings with new eyes. The area was scattered with mining attempts that had failed, shallow shafts dug into promising seams that had pinched out, drift tunnels that had hit water or bad air, exploratory holes abandoned when investors lost interest. Most were dangerous, unstable, filled with bad air or prone to collapse. But a few had been properly timbered and remained structurally sound even after years of abandonment. He found what he was looking for on a south-facing slope 2 miles from the main mining camp. Someone had driven a drift tunnel approximately 40 feet into a sandstone cliff face, following what they had hoped was a coal seam, but which had turned out to be only a thin layer of low-quality lignite not worth extracting. The tunnel was 8 feet wide and 7 feet high at the entrance, narrowing slightly as it penetrated the mountain. The walls and ceiling were solid sandstone with no signs of fracturing or instability. Timber supports had been installed every 6 feet, but they appeared to be precautionary rather than necessary. The rock itself was holding firm. Gareth stood at the tunnel entrance on an afternoon in late April and felt the temperature difference immediately. Outside, the spring air was perhaps 50 degrees. Inside the tunnel, even just 15 feet from the entrance, the temperature felt noticeably warmer, probably close to 60 degrees. He walked to the back of the tunnel and found it even more pronounced. The deep interior held steady warmth that had nothing to do with sunlight or outside air temperature. This was the mountain's baseline temperature, the thermal equilibrium of stone, insulated by dozens of feet of earth and rock. He placed his hand against the tunnel wall. The sandstone was cool, but not cold, somewhere around the temperature of a root cellar. This stone, unheated, already provided a baseline temperature far above what his cabin achieved on the coldest winter nights. And if he heated this stone deliberately, systematically, the thermal mass involved would be enormous. Gareth filed a claim on the abandoned mine entrance in early May of 1874. The process was simple, since nobody else wanted land that had already proven worthless for mineral extraction. He paid the recording fee at the county office in Leadville and walked out with a deed to 20 acres of mountainside, including the tunnel and surrounding cliff face. The county clerk looked at him with obvious confusion when Gareth explained he planned to build a residence there, not reopen mining operations. Word spread quickly through the small mining community. By the time Gareth returned to the site 3 days later with a wagon load of tools and supplies, Idris Llewellyn was waiting for him. Idris had been Gareth's closest friend since both men had arrived in Colorado from Wales in 1871. He was a good man, careful underground and reliable above it, but the expression on his face showed deep concern. "Gareth, Buck, people are saying you've gone mad with grief," Idris said in Welsh, their private language, in a camp full of English and German speakers. "Building into a played-out mine? Living in a hole in the mountain? This is not the way forward." Gareth set down the timber he was unloading and faced his friend directly. "The cabin where Gwyneth and Rhys died could not hold heat. I will not build another cabin that fails the same way. Stone holds warmth. I have tested this underground. I have measured it. A home built into stone, heated properly, will maintain temperature through the coldest night." Idris shook his head slowly. "Stone is cold. Gareth, everyone knows this. Why do you think we build with wood? Stone will make it worse, not better." "Stone feels cold when it is cold," Gareth replied. "But stone heated becomes a reservoir of warmth. Wood does not do this. I am not asking you to understand. I am telling you what I will build." The conversation with Idris was private and respectful. The mockery from others was neither. Dafydd Maddock, whose cabin was nearest to the main mineworks, started calling it Bedwyrs Tomb within a week. The name spread. Men made jokes during shift changes about Gareth burying himself alive, about digging his own grave, about going underground permanently. Some of it was meant as dark humor, the rough jokes miners made about everything. Some of it carried real contempt for a man who thought he knew better than generations of frontier building practice. Cadogan Pritchard, the mine superintendent and one of the few educated men in camp, approached Gareth in early June with what seemed like genuine concern. "Mr. Bedwyr, I understand you are still processing your loss. Perhaps you should consider returning to Wales for a time, being with family while you recover your equilibrium." "My equilibrium is sound," Gareth replied. "My home will be built into that mountain by autumn. You may inspect it then, if you wish." Pritchard left, shaking his head, and that night Gareth heard men in the boarding-house saloon laughing about the Welsh lunatic building a cave to live in, like a bear. Gareth began construction on June 3, 1874, working alone because no one would help with a project they considered doomed. His first task was clearing debris from the tunnel entrance, fallen rock, rotted timber, and accumulated dirt from 3 years of abandonment. He worked methodically, carrying out loads in a wheelbarrow he had built specifically for navigating the uneven ground between the tunnel and a flat area 50 yards downslope where he dumped waste material. The clearing took 9 days. When finished, he had a clean tunnel 40 feet deep with sound walls and ceiling. The entrance measured 8 feet across and 7 feet high. He decided to build his living space in the front 20 feet of the tunnel, leaving the back section for cold storage and coal supply. The stone walls and ceiling already existed. He needed to add only a front wall with a door and window plus interior divisions for a sleeping area and workspace. Before building any wall, Gareth spent 3 days studying the rock face and planning his fireplace location. This was the critical innovation, the element that would make his design work or fail. He needed to heat the stone mass itself, not just the air inside his shelter. After careful examination, he selected a section of the tunnel's right wall approximately 12 feet from the entrance where the sandstone was particularly dense and showed no cracks or mineral intrusions. Using a hammer and chisel, he began cutting shallow channels into the rock face. The work was brutal. Sandstone was softer than granite, but still required hours of patient chipping to create even shallow grooves. He cut 5 horizontal channels, each 1 inch deep and 3 inches wide, running 6 feet across the wall face. The channels were spaced 8 inches apart vertically, creating a ladder pattern across a section of wall, roughly 6 feet wide and 3 feet high. The purpose of these channels was to increase surface area and create pathways for heat to penetrate deeper into the stone. When he built his fireplace against this prepared wall and burned coal directly against the rock, hot gases would flow through the channels, heating not just the surface but the stone mass behind it. The more stone he could heat, the longer it would radiate warmth after the fire died down. After completing the channels, Gareth began gathering stones for his fireplace. He needed flat pieces that would stack securely and withstand repeated heating and cooling without cracking. He found what he needed along a creek bed half a mile from the tunnel, carrying loads of stone up the mountainside over the course of a week. The stones were a mix of granite and dense shale, both materials known for thermal stability. The fireplace construction took 12 days. He built it directly against the channeled rock face, creating a firebox 2 feet deep and 3 feet wide. The design directed heat and exhaust gases against the prepared stone wall, forcing thermal energy into the channels he had cut. The fireplace Gareth built was unlike any standard frontier construction. Most cabins used simple stone fireboxes with straight chimneys, designs meant to draw smoke efficiently while radiating modest heat into the room. Gareth's design had different priorities. He needed maximum heat transfer into the stone mass behind the firebox, which meant controlling the path of hot gases before they escape through the chimney. He created a baffle system using flat stones positioned to force exhaust gases upward across the channeled rock face before allowing them to enter the chimney proper. The hot gases, instead of rising straight up and out, had to travel horizontally across the heated channels, spreading thermal energy across the entire prepared section of wall. The baffle stones were positioned at precise angles, creating a maze that slowed gas flow and maximized contact time between hot exhaust and cold stone. The chimney itself was built inside the tunnel, running up the right wall and exiting through a hole Gareth had carefully widened in the tunnel ceiling. The hole was positioned to vent smoke above the cliff face where wind would disperse it. He lined the chimney with stones mortared with clay he had dug from a deposit near the creek and mixed with sand and water. The chimney was narrow, only 6 inches in diameter, which created strong draft, but also meant gases had to compress and accelerate, increasing their temperature as they flowed past the heating channels. While the clay mortar dried, Gareth began work on his front wall. He had hauled logs from a stand of pine 2 miles distant, selecting trees between 10 and 12 inches in diameter. Each log required felling, limbing, cutting to length, and dragging to the site using a horse he had borrowed from a sympathetic miner who thought the project was foolish but admired Gareth's determination. The front wall design was straightforward. He sank 2 vertical posts into holes he had dug and filled with stone, creating a frame 8 feet wide. Between these posts, he stacked horizontal logs, notching them to fit tightly together. Unlike a traditional 4-walled cabin where all walls were log construction, Gareth only needed this single wall to close off the tunnel entrance. The stone tunnel walls and ceiling already provided 3 sides of his shelter. He left a space for the door on the left side of the wall and a smaller opening for a window on the right. The logs were chinked with the same clay mixture he had used for the chimney, packed tightly into gaps, and smoothed on both sides. The work went quickly compared to the fireplace construction. Within a week, the wall stood complete except for the door and window installations. The door was built from pine planks 2 inches thick, reinforced with crosspieces and hung on iron hinges Gareth had purchased in Leadville. The hinges were expensive, costing nearly a week's wages, but he needed strength and reliability. The door opened inward into the tunnel space and was fitted with a heavy wooden bar that dropped into iron brackets mounted to the stone tunnel wall. The exposed coal seam in the tunnel's left wall became the key to Gareth's entire heating strategy. The seam was 18 inches thick at its widest point, running diagonally through the sandstone approximately 15 feet back from the entrance. Previous miners had tested it and deemed it too thin and too high in sulfur content for commercial extraction, but for Gareth's purposes, it was perfect. He had unlimited fuel literally embedded in the wall of his home. He built a second, smaller fireplace directly against this coal seam. The design was simpler than his primary heating fireplace, just a basic firebox with a short chimney that vented through another hole he cut in the tunnel ceiling. This fireplace served a dual purpose. First, it allowed him to mine coal without leaving his shelter. He could chip chunks directly from the seam, let them fall into the firebox, and burn them immediately. Second, and more importantly, burning coal against the seam heated the surrounding sandstone, turning another section of his tunnel wall into radiant thermal mass. The coal seam was backed by the same dense sandstone that formed the rest of the tunnel. When Gareth burned coal against this wall, heat penetrated deep into the stone. He calculated that he had approximately 600 cubic feet sandstone surrounding his living space that could be heated and would subsequently radiate warmth. The weight of this stone mass was enormous, roughly 50 tons of rock that could absorb and store thermal energy. Other miners who occasionally visited the construction site in July and August focused their mockery on this coal-burning fireplace. Dafydd Maddock examined it during one visit and shook his head with theatrical disgust. "You are burning good coal to heat stone, Bedwyr, stone that will leach every bit of warmth and give you nothing back. You could be selling that coal or burning it sensibly in a proper stove. Instead, you waste it heating a mountain." Gareth did not argue. He simply continued working. He had learned that explaining thermal mass principles to men who had already decided he was mad accomplished nothing. They would understand when winter came, or they would not understand at all. Either way, his design would work based on physics, not opinion. By mid-August, both fireplaces were complete and functional. Gareth conducted his first serious heating test on August 19th, a cool evening when outside temperature dropped to 43 degrees. He burned coal in both fireplaces for 4 hours, stoking them heavily to achieve maximum heat output. Then, he let both fires die completely and began measuring temperature at hourly intervals. The results exceeded even his optimistic calculations. The stone walls radiated heat for 16 hours after the fires went out. Interior temperature peaked at 78 degrees and declined slowly, reaching 62 degrees a full 16 hours later when outside temperature had dropped to 37 degrees overnight. The stone had absorbed enormous amounts of thermal energy and was releasing it exactly as he had theorized. The sleeping platform Gareth built in late August was positioned against the back wall of his living space, 15 feet from the entrance where the tunnel narrowed slightly, and the stone stayed warmest. He constructed it from pine planks laid across a frame elevated 2 feet above the tunnel floor. The elevation served two purposes. It kept him off the cold ground and created storage space beneath for supplies that needed to stay dry but did not require warmth. He built the platform 7 feet long and 4 feet wide, large enough for one person to sleep comfortably with space for extra blankets. The platform's position against the heated stone wall meant radiant warmth would reach the sleeping area throughout the night. He tested this by heating the stone and lying on the platform at various intervals, noting how warmth from the wall created a noticeably more comfortable sleeping environment than any position closer to the entrance. The window installation happened in early September. Gareth had purchased 4 panes of real glass in Leadville, an extravagance that cost him nearly 2 weeks' wages, but which he considered essential. Glass allowed light to enter while preventing heat loss far more effectively than oiled paper or scraped hide. He fitted the panes into a wooden frame he had built with careful joinery, creating a window that could be opened in summer for ventilation, but sealed tightly in winter. The window faced south, positioned to catch maximum daylight during short winter days. Gareth built interior shutters from thick planks that could be closed at night to add another layer of insulation. The shutters were hinged to swing inward and could be secured with a simple wooden latch. When closed, they created a dead air space between glass and wood, that further reduced heat loss. The interior division between living space and storage area was minimal, just a canvas curtain hung from the tunnel ceiling at the 20-foot depth mark. Behind this curtain, the tunnel extended another 20 feet into darkness, where temperatures stayed consistently cool year-round. This space would serve as a root cellar and coal storage area. Gareth could mine coal from the exposed seam and stockpile it here, keeping fuel supply literally within arm's reach during winter storms. By mid-September, the structure was functionally complete. Gareth had a front wall with door and window, 2 functional fireplaces with properly drawing chimneys, a sleeping platform, basic shelving for supplies, and a divided living space that used the tunnel's natural geometry. The construction had taken 3 months and 9 days of steady work. He had spent approximately $60 on materials, glass, iron hinges, tools, and incidentals, plus uncounted hours of labor. The result looked strange to anyone accustomed to conventional cabins. 3 walls were bare stone. Only the front wall was wood. The ceiling was stone. The floor was packed earth. There were no corner notches, no decorative elements, no resemblance to traditional frontier architecture. To visiting miners, it looked unfinished, primitive, more like an improved cave than a proper home. Gareth moved his belongings into the completed shelter on September 23, 1874. He owned little: clothes, bedding, cooking implements, mining tools, and a few books in Welsh he had brought from Carmarthenshire. Everything fit easily in the space he had created. The shelter felt austere but functional, and the stone walls gave it a quality of permanence that wood construction lacked. This structure would not rot, would not burn, would not shift or settle with changing seasons. He spent the last week of September conducting systematic heating tests. Each evening he would burn coal in both fireplaces for varying lengths of time, then measure how long the heated stone maintained elevated temperature. He recorded everything in a notebook, creating a data set that showed clear patterns. 2 hours of intense burning raised interior temperature approximately 30 degrees above baseline, and that elevation persisted for 8 to 10 hours. 4 hours of burning raised temperature 45 degrees with warmth persisting for 14 to 16 hours. The stone's thermal behavior was remarkably consistent. Once heated to a given temperature, it released energy in a predictable curve. The rate of cooling was slowest in the first few hours after heating stopped, then accelerated slightly before leveling off again as the stone approached equilibrium with surrounding earth temperature. Gareth could predict with reasonable accuracy what interior temperature would be at any point in the cooling cycle based on how long and how intensely he had burned coal. Early October brought the first genuinely cold weather, nighttime temperatures dropping into the 20s. Gareth burned coal on the evening of October 7th for 3 hours, achieving an interior temperature of 71 degrees by 9 o'clock. He banked both fires and went to sleep on his platform. When he woke at dawn, interior temperature had dropped to 59 degrees, while outside temperature was 24 degrees, a 35-degree differential maintained passively through the night by radiant heat from stone. He walked to the main mining camp that morning and stopped at Idris Llewellyn's cabin. Idris was awake, feeding split pine into his fireplace after a cold night. His interior temperature, even with the fire burning, was perhaps 45 degrees. The cabin walls showed frost on interior chinking where moisture had condensed and frozen overnight. "How was your night in the cave?" Idris asked, expecting complaints about cold and discomfort. "I slept warm," Gareth replied. "The stone holds heat as I knew it would. You should visit tonight and see for yourself." Idris did visit that evening, bringing Cadogan Pritchard with him. Both men examined the fireplaces, the channeled stone walls, and the simple but solid construction. Gareth burned coal for 2 hours while they watched, explaining how heat penetrated the stone mass and would radiate back through the night. They felt the warmth building in the tunnel space, saw the thermometer reading climb, but remained skeptical. November brought snow to the high country around Leadville. The first storm deposited 8 inches on the 6th of the month, and temperatures began their steady decline toward winter lows. Gareth stockpiled coal in the back section of his tunnel, chipping chunks from the exposed seam during evenings and stacking them where they would stay dry and accessible. By mid-November, he had nearly half a ton of coal ready, more than enough to last through the hardest winter months. Other miners were stacking firewood. The standard calculation was 4 cords per cabin for a severe winter, possibly 5 if cold persisted into April. Men spent October and early November felling trees, cutting rounds, splitting logs, and hauling wood to their cabins. The work was exhausting and time-consuming. A single cord represented roughly 128 cubic feet of stacked wood, the product of many days of labor. Gareth's coal supply, by comparison, took minimal effort to gather. He simply chipped it from his wall as needed. The energy density of coal far exceeded wood. 1 ton of coal contained roughly the same heat energy as 4 cords of wood, but occupied a fraction of the space and required far less handling. This efficiency was lost on his critics, who saw only that he was burning valuable coal to heat stone, rather than selling it or using it in a conventional stove. Dafydd Maddock stopped by in late November, ostensibly to borrow a tool, but actually to inspect Gareth's preparations. He looked at the modest coal pile and shook his head. "You will freeze, Bedwyr. You have fuel for perhaps 3 weeks of serious cold. I have wood stacked to the roof. When your coal runs out and the real winter comes, you will understand your mistake." "The real winter will prove my design sound," Gareth replied calmly. "You are welcome to shelter here if—" "Your wood runs short." Maddock laughed as if this were a ridiculous joke and left. But Gareth noticed that several other miners had begun asking questions about his heating system. Men who worked the same shifts underground had seen him testing coal types and examining stone formations with unusual interest. A few had visited the tunnel cabin and felt the warmth radiating from heated stone walls. Word was spreading that perhaps Bedwyr's cave was not as foolish as it appeared. The mine superintendent, Cadogan Pritchard, visited again in early December with a proposal. "Mr. Bedwyr, I would like to conduct a formal test of your heating system against conventional cabin heating. We could measure fuel consumption, interior temperature maintenance, and compare efficiency. If your design works as you claim, it would be valuable information for the company and for miners building new shelters." Gareth agreed immediately. He had nothing to hide and welcomed documentation of what he knew would be successful results. They scheduled the test for mid-December, when cold weather would be established but before the deepest winter arrived. Pritchard would provide thermometers and recording materials. Gareth would simply operate his heating system as he normally would, while Pritchard took measurements and compared results to data from conventional cabins. The December storm arrived on the 18th with unusual ferocity. Snow began falling before dawn and continued through the day and into the night, accumulating at a rate of nearly 2 inches per hour. Wind drove the snow horizontally across the mountainside, creating drifts that buried cabins to their windowsills. Temperature dropped to 7 degrees above zero by evening and continued falling through the night. By dawn on the 19th, the thermometer Gareth had mounted outside his entrance read 4 degrees below zero. Gareth had burned coal on the afternoon of the 18th for approximately 2 hours, heating his stone walls thoroughly before the storm's full intensity arrived. When snow began falling heavily, he closed his door and shutters, sealing the tunnel cabin against wind and cold. Interior temperature when he sealed the space was 74 degrees. He did not light the fireplaces again that night. He wanted to test whether the heated stone alone could maintain livable temperature through a genuinely severe storm. He checked his interior thermometer every 2 hours through the night. At 8 o'clock in the evening, interior temperature was 70 degrees. At 10 o'clock, 67 degrees. At midnight, 63 degrees. At 2 in the morning, 60 degrees. At 4 o'clock, 58 degrees. By dawn, when he finally relit the coal fireplace, interior temperature had dropped to 55 degrees. Outside temperature was 6 degrees below zero. The stone walls had maintained a 61-degree differential through the coldest night so far that winter, providing comfortable sleeping temperature without any active heating for 14 hours. Gareth opened his door at mid-morning on the 19th to find snow drifted 4 feet deep across the entrance. He shoveled a path to clear air and saw that the entire mining camp was buried. Smoke rose from cabin chimneys throughout the valley, everyone burning wood furiously to combat the cold. He could see Daffod Maddox's cabin 200 yards downslope, smoke pouring from the chimney in a thick column that indicated a roaring fire struggling to heat inadequate walls. Cadogan Pritchard arrived at noon, having struggled through waist-deep snow to reach Gareth's location. He carried his thermometers and a notebook, already filled with temperature readings from the previous night. His first words upon entering Gareth's shelter were simply, "Remarkable." Pritchard had spent the night in the company boarding house, a large log structure that housed 12 miners. Despite having 2 large stoves burning continuously, through the night interior temperature in the boarding house had dropped to 38 degrees by dawn. Men had slept fully clothed under multiple blankets and still woke shivering. Pritchard himself had been unable to sleep due to cold. "Your interior temperature?" Pritchard asked, though he was already reading Gareth's thermometer mounted on the stone wall. 55 degrees at dawn, Gareth replied. "I have only just relit the fireplace. Last burning was yesterday afternoon, approximately 16 hours ago." Pritchard recorded the information carefully, then spent an hour examining the stone walls, feeling residual warmth still radiating from sections that had been heated the previous day. Winter, 1874 through 1875, became historically severe across Colorado's high country. The pattern established in mid-December continued through January and into February, sustained cold, punctuated by massive snowstorms that buried the landscape under accumulating layers of white. Temperature records kept at the Leadville Assay Office showed 27 consecutive days in January, when the mercury never rose above zero. Nighttime lows reached 28 degrees below zero on multiple occasions. The mining camp struggled. Work at the coal mine continued because men needed wages to buy supplies, but shifts were shortened when cold became dangerous. Several miners suffered frostbite walking to and from the mine works. One man lost 3 toes after his boots failed during a shift change in extreme cold. The doctor in Leadville, 8 miles distant, could not reach the camp for 2 weeks in late January when roads became impassable. Cabin life became a desperate struggle against cold that never relented. Men burned through their firewood supplies faster than anticipated. Trees close to camp had been harvested in previous years, which meant felling expeditions now required traveling miles through deep snow to find suitable timber. Some miners began burning furniture and floorboards when firewood ran low. The boarding house exhausted its wood supply in mid-January and had to purchase additional cords at inflated prices from entrepreneurs who had stockpiled fuel specifically to profit from scarcity. Gareth's tunnel cabin performed exactly as he had calculated. He burned coal for 2 to 3 hours each evening, heating his stone walls thoroughly. The thermal mass carried him through each night with interior temperatures rarely dropping below 50 degrees even when outside conditions reached their most extreme. His coal consumption was modest, approximately 40 pounds per day during the coldest periods, less when temperatures moderated slightly. His stockpile, which Daffod Maddox had mocked as inadequate in November, proved more than sufficient. Word spread through the camp about the unusual effectiveness of Bedwyer's design. Miners who had mocked the tunnel cabin in summer now asked detailed questions about construction. How deep were the heating channels? What thickness of stone was needed for adequate thermal mass? Could existing mine entrances be converted? Gareth answered every question freely, sketching diagrams in the snow with a stick to illustrate principles of heat transfer and thermal storage. Cadogan Pritchard continued his documentation through January, comparing fuel consumption and temperature maintenance across different shelter types. His data showed that Gareth's design used approximately one-third the fuel of conventional cabins while maintaining significantly higher average interior temperatures. A standard cabin required continuous or near-continuous burning to maintain minimally acceptable warmth. Gareth's system required only a few hours of heating per day, but documentation and data interested fewer people than survival. The brutal winter was testing every structure and every strategy, and the real test was still coming. The blizzard that began on February 7, 1875, was unprecedented in the memory of anyone living in the Leadville district. Snow fell continuously for 68 hours, driven by winds that screamed down from the peaks with enough force to tear roofs from poorly built structures. Temperature during the storm never rose above 12 degrees below zero. The combination of extreme cold, hurricane-force wind, and relentless snowfall created conditions where simply existing outdoors for more than a few minutes meant death. Dafydd Maddox's cabin sat exposed on relatively flat ground with little natural wind protection. He lived there with his wife Era and their two children, a boy of 9 and a girl of 6. The cabin was standard construction, notched logs, mud chinking, a single fireplace, one door, 2 small windows. Maddox had built it himself 3 years earlier and considered it adequate. He had stockpiled 5 cords of firewood for winter, more than most miners managed. By the second day of the blizzard, Maddox's firewood was running dangerously low. The extreme cold and wind infiltration meant his fireplace had to burn constantly at maximum output just to maintain interior temperature above freezing. Wood that should have lasted weeks in normal cold weather was being consumed in days under these conditions. On the morning of February 9th, Maddox realized he had perhaps 12 hours of fuel remaining and no possibility of gathering more while the storm continued. He began burning furniture. The kitchen table went into the fire first, then chairs, then a small cabinet he had built for storing dishes. The wood burned quickly, producing less heat than properly seasoned firewood. By evening on the 9th, he was burning bed frames and floorboards. His wife and children huddled near the fireplace, wrapped in every blanket they owned. Interior temperature, despite the desperate burning, hovered around 28 degrees. At some point during the night of February 9th, Era Maddox made a decision that saved her family. She bundled the children in blankets, woke her husband, and insisted they abandon the cabin and try to reach help. Maddox initially refused. Going outside in the storm seemed like suicide, but Era understood what her husband would not admit. Staying in a cabin that could no longer maintain heat was equally fatal. They would freeze in their beds within hours once the last fuel was exhausted. They left the cabin at approximately 2 o'clock in the morning on February 10th. The journey to Gareth's tunnel cabin, normally a 10-minute walk, took nearly an hour. They struggled through waist-deep snow in complete darkness, following terrain features Maddox knew from memory. Wind knocked the children down repeatedly. Only Era's fierce determination kept the family moving forward when stopping would have meant freezing where they fell. Gareth woke to pounding on his door. He opened it to find the Maddox family collapsed in the snow, the children barely conscious. He pulled them inside, closed the door, and began warming them immediately. His stone walls were radiating steady heat. Interior temperature was 57 degrees, warm enough to prevent hypothermia, but not so warm as to shock frozen bodies. Gareth stripped the wet outer clothing from the Maddox children and wrapped them in dry blankets from his sleeping platform. He positioned them against the warmest section of stone wall, where heat radiating from rock would gradually restore their core temperature. Era Maddox was conscious but shaking violently, her teeth chattering so hard she could not speak. Dafydd sat on the floor near the door, looking defeated and ashamed, unable to meet Gareth's eyes. The children recovered first. Within an hour of being brought inside, both had stopped shivering and fallen into exhausted sleep against the warm stone. Era recovered more slowly, her body having expended enormous energy forcing her family through the storm. Gareth gave her hot tea brewed over his coal fire and wrapped her in additional blankets. By dawn, she was warm enough to speak coherently and explain what had happened. The Maddock cabin had become uninhabitable. Even if the storm ended immediately, the structure would require extensive repair before it could be safely occupied again. The Maddocks had no firewood left and no way to gather more until conditions improved. They would need to shelter elsewhere until spring. Gareth offered his tunnel cabin without hesitation, though the space was cramped for 5 people. The storm finally broke on the afternoon of February 10th. Snow stopped falling, wind diminished to occasional gusts, and weak sunlight appeared through thinning clouds. The landscape had been transformed. Drifts were 15 feet deep in protected areas. The Maddock cabin was buried to its roofline, only the chimney visible above the snow. Other cabins throughout the camp showed similar devastation. Several structures had partially collapsed under snow weight. The boarding house had lost part of its roof to wind damage. Cadogan Pritchard arrived at Gareth's tunnel cabin on February 11th, having heard about the Maddock family's ordeal. He brought proper meteorological instruments, precision thermometers calibrated in his office, a barometer, and recording equipment. He wanted to document the temperature differential that had allowed Gareth's shelter to maintain livable conditions while conventional cabins failed catastrophically during the same storm. Pritchard conducted measurements over the next 3 days. He recorded outside temperature at 4-hour intervals, measured Gareth's interior temperature at the same intervals, and calculated the differential. The results were dramatic and undeniable. On the coldest night of the storm, outside temperature had reached 13 degrees below zero. Gareth's interior temperature 12 hours after his last coal burning was 60 degrees. The differential was 73 degrees. Pritchard documented fuel consumption as well. During the 3-day storm, Gareth had burned approximately 90 pounds of coal total. A conventional cabin maintaining even marginally acceptable interior temperature during the same period would have consumed between 1/4 and 1/2 quart of wood, roughly 400 to 800 pounds of fuel. Gareth's design was achieving superior results with less than 1/4 the fuel consumption. The data was irrefutable. Thermal mass heating using stone walls worked exactly as Gareth had theorized. The Maddock family remained in Gareth's tunnel cabin through the rest of February and into March. The space was crowded with 5 people, but the stone walls maintained comfortable warmth with only modest increases in coal consumption. Gareth burned his fireplaces slightly longer each day to accommodate the additional body heat load and moisture from cooking and breathing. The system adapted easily. By early March, when snow had melted enough that the Maddock cabin could be assessed and repaired, Daffyd Maddock had become a complete convert to thermal mass principles. Other miners began visiting regularly to examine the tunnel cabin and ask technical questions. The most common question was whether the design could be replicated using conventional construction. Could thermal mass heating work in a standard log cabin? Gareth's answer was carefully considered. Yes, thermal mass could be incorporated into conventional structures by building stone interior walls or creating stone heat storage systems within standard cabins, but the efficiency would never match a design that used natural geological features. Building stone walls required enormous labor and materials. Using an existing rock face, as Gareth had done, provided thermal mass that no constructed wall could rival. Idris Llewellyn announced in mid-March that he would build a tunnel cabin in an abandoned mine entrance he had found 2 miles north of the main camp. He asked Gareth to help with the design, particularly the fireplace and heating channel layout. Gareth agreed and spent several days examining Idris's chosen site, evaluating the rock type and tunnel dimensions. The stone was granite rather than sandstone, which had different thermal properties, but the principles remained the same. Heat granite sufficiently and it would store and radiate thermal energy for hours. Construction began in April, when weather moderated enough to allow sustained work. Idris followed Gareth's methods closely, cutting heating channels into the stone, positioning his fireplace to direct heat into rock mass, building a single front wall to close off the tunnel entrance. Other miners watched the construction with interest that would have seemed impossible 6 months earlier. What had been Bedwyrs folly was now being studied as innovative engineering worth replicating. Cadogan Pritchard presented his documented findings to the mine company ownership in late April. His report included temperature data, fuel consumption calculations, and cost analysis comparing thermal mass designs to conventional construction. The conclusion was unambiguous. For high-altitude mining operations where fuel costs were significant and winter survival was never guaranteed, encouraging miners to build tunnel cabins using abandoned mine entrances would reduce company costs, improve worker safety, and increase winter productivity by reducing weather-related work stoppages. The company approved construction of 6 demonstration tunnel cabins at various abandoned mine sites around the Leadville district. Gareth was hired as a consultant at premium wages to oversee the designs and ensure proper implementation of heating principles. By summer of 1875, thermal mass heating had gone from scorned innovation to company-approved standard practice. By 1876, tunnel cabins had become common. Throughout Colorado's coal mining districts, the technique spread organically as miners moved between camps, carrying knowledge of thermal mass heating to new locations. Abandoned mine entrances that had been considered worthless suddenly became valuable real estate. Men filed claims on played-out drifts and shallow shafts specifically for their potential as cabin sites, evaluating rock type and tunnel dimensions with the same care they had previously reserved for assessing mineral deposits. The designs evolved as different miners adapted Gareth's principles to varying geological conditions. In areas where sandstone predominated, builders followed his heating channel pattern almost exactly. In granite regions, modifications were necessary because granite's lower porosity meant heat penetrated less deeply, requiring different channel depths and spacing. Some builders working in limestone discovered that while limestone absorbed heat readily, it also released moisture when heated, creating humidity problems that required additional ventilation planning. The most successful adaptations occurred in the southern Colorado coal fields, where exposed coal seams were common. Miners, building into cliff faces containing coal, could replicate Gareth's fuel-in-the-walls advantage, creating shelters that were essentially self-sufficient for heating. One miner named Torsten Lindqvist built a tunnel cabin in Crested Butte, where the coal seam in his wall was thick enough and high enough quality that he sold excess coal to neighbors while still maintaining unlimited fuel for his own heating needs. Not every attempt succeeded. Some miners selected unstable rock formations that required extensive timbering, negating the construction efficiency that made tunnel cabins attractive. Others built in locations with inadequate ventilation, creating dangerous carbon monoxide accumulation from coal burning. 3 miners in the Gunnison district built tunnel cabins that flooded during spring. Snowmelt, because they had failed to consider drainage patterns Gareth had carefully evaluated when selecting his site. But the failures were instructive. Knowledge spread about what worked and what did not. Experienced tunnel cabin builders began offering advice to newcomers, creating an informal body of engineering wisdom specific to this construction type. By 1878, a man planning to build a tunnel cabin could find experienced guidance on site selection, rock evaluation, fireplace design, ventilation requirements, and drainage management. The technique had matured from experimental innovation to established practice with documented best methods. Gareth himself built 2 additional tunnel cabins during this period, both commissioned by mining companies wanting demonstration structures at new operations in remote locations. He refined his techniques with each construction, developing faster methods for cutting heating channels and more efficient fireplace designs that required less coal to achieve equivalent heating. His daily wage for consultation work exceeded what he had earned as an underground miner, but he continued working his regular shifts because he preferred the simple rhythm of mining labor to the complications of becoming known as an expert. The phrase rock-back cabin entered common usage in mining camps, a term that encompassed tunnel cabins and the various conventional structures that incorporated stone thermal mass walls. By 1880, an estimated 200 rock-back cabins existed across Colorado, Wyoming, and Montana mining districts. Gareth Bedwer died on March 14, 1891, in the same tunnel cabin he had built 17 years earlier. He was 53 years old, his health broken by years of underground coal dust exposure that had destroyed his lungs gradually and irreversibly. He died quietly in his sleep on the platform where he had slept since construction was completed, his body warm against stone walls that had never failed to hold heat through the coldest nights. He had never remarried after Gwyneth's death. He had lived alone in his tunnel cabin, working his mining shifts, refining his heating techniques, and helping others who wanted to build similar structures. He had accumulated modest savings that went to distant cousins in Wales who barely remembered him. His funeral was attended by 37 miners, most of whom lived in rock-back cabins they had built using principles he had shared freely. His grave marker in the Leadville Cemetery mentioned only his name, birth year, death year, and the phrase coal miner. There was no mention of innovation, no reference to the heating technique that bore his informal legacy, no acknowledgement that his obsessive response to grief had changed how people survived in one of the harshest climates on the American frontier. But in the mountains, his legacy persisted in forms more durable than carved stone. The tunnel cabin he had built remained occupied continuously through the 1890s and into the 20th century. Miners, prospectors, and eventually tourists used it as shelter, most unaware of who had built it or why. The structure required minimal maintenance. Stone walls did not rot, heating channels continued functioning exactly as designed, and the coal seam in the wall provided fuel for anyone who needed it. By 1900, when the Colorado coal boom had largely ended and mining camps were emptying as people moved to other opportunities, hundreds of rock-back cabins still stood scattered through the mountains. Some remained occupied. Others served as emergency shelters for travelers caught in storms. A few became historical curiosities, their unusual construction noted by settlers who had no knowledge of the desperate winter that had proved their worth. Modern historians who study frontier innovation sometimes encounter references to thermal mass heating in mining camp records from the 1870s and 80s. The technique is noted as an example of adaptive engineering, settlers taking established principles and applying them creatively to extreme conditions. Occasionally, Gareth Bedwer's name appears in these records, usually in footnotes citing Cadogan Pritchard's temperature documentation or company reports on fuel efficiency improvements. But the real measure of Gareth's achievement was never documentation or recognition. It was lives preserved through winters that would have killed people in conventional shelters. It was families who stayed warm while others froze. It was the quiet confidence of knowing that grief transformed into useful knowledge could prevent the same tragedy from destroying others. Gareth had built a cabin that could not fail the way his first cabin had failed. And in sharing that knowledge freely, he had given others the same certainty. The impossible had become routine. Stone heated properly would hold warmth through the darkest, coldest nights, as reliable as geology itself.